Okay, in this video, we are gonna finish problem number 2. We're gonna do the second half, E through H. So remember, we're still working with Zion shoveling those sidewalks, and we've already represented that problem situation as a verbal description, as a table, and as an equation. Now we're trying to sketch a graph of that situation. And there's lots of ways to sketch this graph, but I find it easiest just to think about that table. We've already got this table, right? Right there, and we've got these points that we can plot. So I know that if Zion shovels 0 sidewalks, he'll make $0. I know if he shovels 1 sidewalk, he'll make $20. If he shovels 2 sidewalks, he'll make $40. If he shovels 3 sidewalks, he'll make $60. 4 sidewalks, $80, right? I could even do 5 sidewalks. That's not in my table, but that should be 5 sidewalks, $100, right? So here it turns out to be a line, right? And I'm not sure if we should connect the dots or not. Can he shovel a fraction of a sidewalk and still get paid? It depends on what he works out with the people he shovels for. So if he's allowed to shovel part of a sidewalk and still get paid, this would be a continuous line. But if he's only getting paid for the number of sidewalks he shovels, then really these points are the only points that actually work for him. So it just depends on what he works out. So there's a sketch of that graph. And then F, how many sidewalks would Zion have to shovel to make $100? Now you can use the graph to figure that out. You can use the equation to figure that out. If we just look at the graph, well, $100 is right here. He would have to shovel 5, right? So 5 sidewalks. For folks who prefer to use the equation, you just remember the equations P of S equals 20 times S, and $100 is the profit. So you would plug 100 in for P of S, and then you would solve for S. You would divide by 20 on both sides, and that would leave S equal to 5, right? So either way, using the graph or using the equation, you should be able to get the same answer, 5 sidewalks. Now, what is the slope of your graph? And explain what it means in terms of the problem situation. So remember, slope is rise over run. If I start here, I go up 20, but I go over 1. Up 20 over 1. Up 20 over 1. So my rise over run is 20 over 1. Now, what does it mean? This is the unit rate of change, right? He makes $20 per sidewalk. That's what it means. So Zion makes $20 per sidewalk he shovels, right? So the slope, that unit rate of change, has meaning in terms of the problem. So it doesn't just describe the steepness of the graph, but it has meaning. And then the last question is, what is the y-intercept of the graph? What does that mean? So y-intercept is where it crosses the y-axis. So here's the line. Here's the y-axis. The two of them cross right there at 0, 0. Okay, so the y-intercept is 0, 0. And hint, that also means it's the x-intercept. In this particular case, right, it's also where it crosses the x-axis. That doesn't always happen, but it happened here. So what does that mean in terms of the graph? What does it mean in terms of the problem situation? Well, it means that when he shovels 0 sidewalks, he makes $0, right? When Zion shovels 0 sidewalks, he makes no money, right? So each of these things about the graph has meanings in terms of the real problem.